Our create entity then wants to be able to create bitmap entities and players, and it wants to do so not using resource IDs, but the names of the actual bitmaps, also positions. So our base entity doesn't even have a constructor. That's fine. This is just an interface. And what I want to do is bring in the bitmap entity and the player entity from our previous project. So before I do that, I'm going to create a package, I thought. There we go, the package, and just call this entities. So everything related to entities will be in here. I'll move entity in there, refactor all of my source code. And again, I've made these public, so this shouldn't break much. And when it does, we'll fix it. So I want to add bitmap entity and player here. And while I'm doing that, here's the source code for my space shooter. I know I want my utils. Probably want the jukebox, but I'll grab that later. So yeah, I want utils. And we have a BitmapUtils. We have a generic utils. So I'm going to have a package for this as well. So package utilities. And then let's see if we can drag and drop stuff into this. Let's see where this is. Show in Explorer. That's in my project. Perfect. So it copied over. Drag and drop works. Then I want bitmap entity and the player into entities. And lastly, we can grab the BitmapUtils from our course page. And I apologize for this code looking horrendous on the course website. It's just formatting code is pretty much impossible here. Every time you save this page, it eats my source code and I have to reformat everything. So I'm just going to create a new Java class, BitmapUtilities, remove that and paste that. So very briefly from the top here, filter is a setting that's used whenever we're resampling bitmaps, and it costs a little bit of performance. It might increase the quality, the visual quality of a resampled bitmap, but you just need to test and see if the type of scaling you're doing benefits from the filtering or not. I leave it on by default. You can change it whatever you want. These three items, there is a point object, a matrix object, and then a bitmap factory options object. I declare them here so that I can reuse them in all of the static methods throughout this class. I assume that we will only call a function in this class from a single thread. So these will never be under contention. If you ever go to multithreading in, say, loading of your entities, you're going to have to change this to either create new instances inside of your methods, or use a proper pool. But for as long as we're single-threaded, in our calls into these methods, this will be fine. So I can reuse these objects instead of aggravating the memory manager, the garbage collector. Thank you. There you go. So when I say Q&D pool, that means quick and dirty pool. It's a hack, but it works. And so yeah, there's a bunch of convenience functions we have for scaling bitmaps, so this one is the same as we wrote in our utilities. It takes a bitmap and scale it to another size. This is scaled to target height. I'm pretty sure we have, this one does target width and target height. It's calculate, it does everything this thing does. So I can remove this. In fact, I can remove all bitmap features because I'm pretty sure flip bitmap exists as well, which means I don't need matrix here anymore. So I'm just shortening the other utilities class. So if I go, I just want to check that I actually have a flip bitmap here. Get source, calculate scaling. So here's a rotate, here's a flip. It's the exact same implementation we had in our utilities. And then scale to target height is down here. Same thing, same thing. Now, the reason we want this BitmapUtils with all of this messy code is because we can call load scaled bitmap with either a resource or a bitmap name. So these are doing the same work. In fact, this one taking the name is implemented by way of the one taking a resource ID. So the only thing this is doing is taking your context, taking the name of your bitmap and finding out what the resource ID is, and then it calls load scale bitmap, taking the resource ID, etc. Now, this is more efficient than the way we loaded scale bitmaps before. What we used to do is load the bitmap in full resolution and then scale it down in memory, which means we have a couple of copies of that bitmap in memory at the same time. What we're doing here instead is we are asking the source file how big it is, and then we calculate how much we can scale it at load. So if you go down to calculate sample size, get source info, this is a good example here. By using the bitmap factory options object, you can ask it to only decode the meta information about the file. So the input argument, just decode bounds, we set that to true on the options object. Then we ask the bitmap factory to decode the resource. But what this does now is not load the bitmap to decode it, right? It only decodes the meta information, put it in our options object, and then returns. And then I reset that value just to make sure that the next time we use it, it's not going to cause problems. Next time we probably want to load the file. So when I want to decode a sampled bitmap, that means I want to load a bitmap at a lower resolution than what it is natively. I can say, instead of looking at every pixel in the bitmap when bringing it into memory, I might want to load it at half resolution. And by using decode sample bitmap, we only have to actually look at every other pixel. So the loading routine in the Android operating system does half as much work. And then the resulting object in memory takes up half the amount of space and whatever. You don't have to grab all of these details just now. If you check out the playlist I have linked to on the course website about Android performance patterns, there is a great lecture from McAnis, I think, talking about this specific thing, how to load bitmaps efficiently rather. And most of this code is from Google's own documentation, so it's already out there, and that's why you get this to just make use of. And yeah, ask me in the forum if you want specific links to where these functions are properly explained, and I'll provide them so you don't have to go hunting if you haven't already found them on the course website. So we now have the utilities and BitmapUtils, and in my level manager, I want to be able to create a bitmap entity. Let's start with renaming this to static entity. We don't care that it's a bitmap entity because everything will be a bitmap entity. But for now, a static entity is going to be anything that doesn't move. Static entity doesn't exist, so we're going to refactor and rename this bitmap. Refactor, rename, static entity. Okay, so here's our old bitmap entity now renamed to static entity. And I want to bring in that class. And then I want these arguments, so I can write a new constructor for it. Static entity takes a sprite name, positions, all kinds of stuff. My load bitmap is going to do the same. Take those values. But instead of calling this decoding resources manually using scale to target height, so right here we're loading in full resolution resource, and then we're scaling it, then removing. What we're going to do instead is do bitmap equals BitmapUtils load scale bitmap. I have the need for a context, so that's going to be our engine. No, not engine, game, sorry. You remember this is the static reference inside of our entity. So game. Game is a surface view. Surface view is part of the view hierarchy, and therefore it has access to the getContext method. So we're going to use that for our context. We will send in the sprite name and then our target width and target height. So this is interesting. When we deal with width and height, I definitely do not want the bitmap width and height. In fact, we're going to hard code this for now to something, let's see. Let's do static final float because it's going to be in meters, and just call this default dimension 1f. So 1 meter. This is not going to be accurate right now, obviously, but let's hard code this. So width is going to be default dimension, height is going to be default dimension. And so for loading our scale bitmap, that's going to be width and height. But this takes an integer. So we want to translate this to pixels from our meters. The way we're going to do that proper is by having a viewport that the game owns, a camera that tells us how big is a meter on my screen right now. We can do that if I go to my game class, and I realize here that I don't have access to the game reference, so we can fix that real quick. I'm in the game class now. I'm just going to go over to entity, actually make this public so that the game class can reach it. And let's, much like this, we're going to create some convenient functions here. Convenience. I want world to screen for height and width. So world to screen x, which takes a float, and because it's x, this is going to be width. So width in meters. And that means we're going to return an integer because we're to screen. Screen is always pixels. Pixels is always going to be full numbers, I think. I don't think they're using twips or anything in between. Then I want a world to screen y with height in meters. And because we don't have a viewport, we're just going to go with anything at this point. So let's say we just return an integer, which is width in meters times 50. So our conversion rate now is 1 meter is 50 pixels on the screen. Obviously, this hard-coded number is going to change once we have the viewport in place, so we can get a real value and an adjustable value. And then we do height in meters times 50. And note this. 50 is a temp to be replaced, obviously. So we have utilities. We can go back to our bitmap entity. Where is it? No, static entity, sorry. Static entity, load bitmap. So instead of passing in width, what we want to do is integer final, actually. Width in pixels equals game world to screen x my width. This math is probably going to be hidden later when we say create a bitmap pool or something similar, so that the bitmap pool is aware of the meter and pixel conversion. We don't have to do it in every entity where we need this conversion. So we pass in a world measurement, we get a screen measurement, which is what the bitmaps need to be. Then we pass in height in pixels and width pixels. Sorry, that's not a member, it's a local. That's pretty much it. We probably want to check if it returns null or not. No, in fact, it throws something. Load scale bitmap, let's do surround with try and catch. There we go. Because we can run out of memory, there can be all kinds of stuff that goes wrong. If you're catching only to print the exception, there is no point in catching. But in this case, we're going to live with it. And let's see, bitmap is null by default. That's fine. So we might want to... No, actually, we're going to leave that. That's fine. Render is needs to be public, otherwise we're not inheriting. So now I'm just going to fix this so we can actually use it. Go to level manager, see what's missing. Cannot be created because the constructor is not public. We have the draw method. We have the destruction, making sure we don't destroy something we don't have. All of this should be replaced with a bitmap pool. It's part of the assignment, I think. We might do it together. Either way, it's silly that each entity keeps its own bitmap, because we're going to have, 50 copies of this in the world, maybe 100 copies. We want them to use the exact same bitmap. Yeah, let's do a pool together. Let's see. Constructor static entity cannot be applied. Here's my player. Oh, right. So my player is broken now. Well, that makes sense. It needs to take the same type of arguments, in fact. So I'm just going to grab these. Don't need to call super, because I'm pretty sure Java does that itself. No? Maybe not. There's no default constructor in static entity. Right, no, fine. We just call super with the same arguments. And also, I forgot to set our position. Our overrides need to be public. But respawn, in fact, does not need to exist, so I might remove that. Update can be emptied for now. And needs to be public. Just going to leave this as is for now. But that's the player. Player calls static entity with its argument. I'm not making use of the positions, so let's make sure. X equals xpos. And of course, this should be meters. So what we want to do is multiply it with our conversion rate. No, sorry, that's actually, hang on. Yes, position is in meters. Let's not worry about this right now. We're gonna get to this when we render these things anyway. So we're just gonna set them for now. All the objects is going to overlap because they're going to be positioned at pixel values, and so they won't be separated far enough, whatever. We get to that when we render. Just make sure that it all runs. And we don't have a render going on yet, right? Our game class creates the level... Oh, sorry, what happened? Our game class creates the level manager. The level manager creates the objects and holds them in entities to add, in fact, because we don't have an update. We are never calling add and remove entities to make sure they're added to the active lists. So this one needs an update. Then we need to get that list from the level manager so we can render it, and so on and so forth. Let's do that in another video.